So this is the Unit 4 review sheet video for the review key. All right, so here we go. We start off with inverse trig functions. Okay, so we first start off with cosine of 5 pi over 6. And for all this whole test, you can use the formula sheet. It will be provided to you the day of the test. So we look at the first part. Since the first part's not a inverse, we just find the value for cosine of 5 pi over 6 on the unit circle. Cosine of 5 pi over 6 is going to be negative root 3 over 2. So then we have to find the inverse sine of that. Now again, remember for inverse sine, we have to use only the right-hand side of the unit circle. And the right-hand side of the unit circle, to find negative root 3 over 2, we got to go backwards on the unit circle. So it's going to be negative pi over 3. Number 2. All right, this is the inverse cosine. So for inverse cosine, we can only use the top half of the unit circle. Looking for square root of 3 over 2, which is going to be pi over 6. Then to find the tangent of pi over 6. So the tangent of pi over 6 is sine over cosine. All right, the sine of pi over 6 is 1/2. The cosine of pi over 6 is root 3 over 2. Okay, so what we're going to do is figure out what that value is. We're going to multiply by its reciprocal on the bottom to bring it to the top. Okay. All this stuff on the bottom cancels. The 2's cancel, which you get 1 over the square root of 3. Since we're not allowed to keep the square root of any number on the bottom of our fraction, we're going to multiply it to the top. So we get 1 times the square root of 3 is just the square root of 3. The square root of 3 times the square root of 3 is the square root of 9, which is just 3. So this is your answer. We talked about in class, like just knowing the tangent of pi over 6 is going to be root 3 over 3, or anything with a 6 on the bottom of the denominator would be root 3 over 3. Anything with a 3 in the denominator would be just root 3. And anything with a 4 in the denominator is going to be 1. Now, it could be positive or negative for all those, but that's what it is. All right, inverse tangent, kind of like inverse sine, can only use the right-hand side of the unit circle. Trying to find out where the tangent is going to be 1. Okay, the only place that works on the right side of the unit circle is at 0. So 0 radians. So we have the cosine of that. We have the inverse sine of that answer. So next we do the cosine of 0. So at 0 radians, what is the cosine? The cosine is 1. Okay, so we're looking at, this is 0 degree, or 0 radians, sorry. And the cosine of 0 radians is going to be 1. And finally, we have the inverse sine of 1. Again, we can only use the right-hand side of the unit circle. And the inverse sine of 1, where 1 is going to be the y value, is going to be at pi over 2. So we're just looking at the unit circle, back and forth between radians and points, to find our answer. Finally, number 4, we have the tangent of 5 pi over 4. So if we look at 5 pi over 4 on the unit circle, you're going to get negative root 2 over 2 divided by negative root 2 over 2. I'll write it down. And since those are the same numbers, that gives you a value of 1. So now we find the inverse sine of 1, and then the cosine of whatever that answer is. All right, so the inverse sine of 1, we can only use the right-hand side of the unit circle, which is pi over 2. And the cosine of pi over 2 is 0. And that's it. So that is the inverse trig functions. All right, there's actually a typo on this. This should be for all possible values, for all values of x between 0 and 2 pi. Okay, so it's not a big deal. You probably wouldn't have known about it anyway, but I'm going to put it in there just because it is technically that. All right, so to solve these, we have to get the trig functions by themselves. The best way to do it in the first one is to subtract 5 sine of x from both sides. Okay, that cancels that out. We're left with the square root of 3 equals, this gives you 3 minus 5 is negative 2 sine of x. Then we divide both sides by -2 to get the sine of x by itself. So those go away. So we have the square root of 3 over 2, and it's negative, equals the sine of x. Now what we have to do is find out all the places on the unit circle in one rotation around the unit circle from 0 to 2 pi where the y value is -√3 over 2. It happens twice. It happens at 4 pi over 3, and it happens at 5 pi over 3. Number 6. 4 cosine squared of x equals 3. We have to divide both sides by 4 first. So we have cosine squared of x equals 3 over 4. Okay, to get rid of the squared, we're going to square root both sides of our equation. Squared and square root cancel, so we get cosine of x equals √3 over, the square root of 4 is just 2. Now again, one thing that I have mentioned before that many students will forget is because we did the square root on both sides of the equation, it should be plus or minus. So now we're looking for where is cosine, where is the x value going to be positive or negative √3 over 2? Happens in 4 places. Pi over 6, 5 pi over 6, happens at 7 pi over 6, happens at 11 pi over 6. All right. Number 7. In this case, we've talked about this before in class. Any rules that you have for solving equations that we've normally done can be applied to these trig equations. Okay, we can almost rewrite this if we wanted to. I'll put it in a different color just so I separate it. Is 2x squared plus 1x minus 1 equals 0. Okay, what we can do is we can factor this quadratic. It's basically a quadratic trig function. We can factor the quadratic and then find the solution to both factors. So if we factor this, we're going to get, I'm going to change back to blue so you can see the difference. We're going to get 2 cosine of x, and then cosine of x. The factors of -1, two numbers that multiply to be -1 and add up to be +1, also dealing with the 2, would be 1 here and -1 here. Okay, if we define that middle term, 2 times +1 is 2, and then 2 minus 1 is +1. So we get that term in the middle. So now what we have is we have two factors. We have 2 cosine of x minus 1 equals 0. We have cosine of x plus 1 equals 0. So we solve both of these for cosine of x. So the first one, we're going to add 1 and divide by 2. The second one, we're going to just subtract 1. So now we have both factors solved for cosine. We have to find out what those values are in the unit circle for those two problems, or those two factors. So we're looking for where cosine is positive 1/2. It's going to be in 2 spots at pi over 3 and also at 5 pi over 3. And then we're looking for where cosine is -1. It only happens once at pi. So those are the 3 different answers you should have for this problem in number 7. Number 8. To solve this one, the first thing we have to do is actually get all the stuff on the same side. So we're going to add sine of x to the left. All right, so that will go away. Now you can't combine those because they're not like terms. The top one is sine squared, the bottom one is just sine. So you get 2 sine squared x plus sine of x equals 0. All right, this again, you can rewrite this if you wanted to help yourself out, to get rid of the trig functions temporarily. Would be 2x squared plus x equals 0. What just happened to my pen? Sorry. I don't know what happened. Equals 0. There we go. All right, so what we can do with this is we can take the greatest common factor of the x's out, or the same thing, we could do the same thing with the trig function. We can do the greatest common factor of sine x out. We'd be left with 2, sorry, hold on. We're taking the sine of x out. Be left with 2 sine of x, because there was 2 of them there, plus 1, and that equals 0. So we're taking the greatest common factor out of sine of x. Kind of like the last problem, we take both of our factors and set them both equal to 0. All right, the first one's already solved because sine of x equals 0, so that one's done. The second one, we have to subtract 1 and divide by 2. So we have sine of x equals negative 1 over 2. And then now that we have them both solved for sine, we can now put those values, find the values on the unit circle. So where's sine equals 0? It's in 2 spots. Actually, it's in 3 spots. There's 0, there's pi, and there's one people always forget, which is 2 pi. 0 and 2 pi occupy the same spot, but they're both included. All right, for sine of x equals negative 1/2, that is in 2 spots. We're going to get 7 pi over 6, and we're going to get 11 pi over 6. So there's a total of 5 answers for this problem. Next. This one comes with a hint. All right, without this hint, it would be probably pretty hard to solve it because you wouldn't want to know what to do with the cosine squared of x. But we can take the cosine squared of x and use the Pythagorean identities that we had from Unit 2 to solve this. So we're going to take the cosine squared of x and make it into a 1 minus sine squared of x equals 2 sine of x plus 2. Okay. Now what I'm going to do is I'm going to move all the stuff on the left over to the right because I want to get that sine squared to be positive. So I'm going to subtract 1 and add sine squared of x. All right, so that will go away. Now, again, I can't combine the 2 sine of x and the sine squared of x because they're not like terms. One's being squared and one is not. So I'll just rewrite them in order. So I have sine squared of x plus 2 sine of x, and then 2 minus 1 is just positive 1, and that equals 0. All right, much like the problem in number 7, this is a factorable problem. This would be as if I did x squared plus 2x plus 1. Okay, if I factor that and put the signs instead, I'd have sine of x plus 1, sine of x plus 1 equals 0. All right, the two factors are the same, so I just need to solve for one of them. Sine of x is equal to negative 1, and then find that value on the unit circle. There's only one spot where sine of x is negative 1, and that would be at 3 pi over 2. Number 10. Okay, so to solve this is a throwback to Unit 2 in first semester where we were solving radical equations. To do this, first we're going to subtract cosine of x over to the left, over to the right. We have negative root. Actually, I lied. I'm not going to do that. Skip that. We're going to make my life a little bit easier. I just realized something. All right, what we're going to do is actually add the square root of negative 3 cosine squared of x plus 1 to the other side. Okay, so that will cancel out. We'll get cosine of x equals the square root of negative 3 cosine of x plus 1. I did that because I didn't want it to divide by negative and it's 2 steps versus 1. So this should make it a little bit easier. All right, what we do next is we have to get rid of that square root sign. So we're going to square both sides of our equation. So the left side becomes cosine squared of x. The right side, the 2 squared and square roots go away. We're left with negative 3 cosine of x, or cosine squared of x. Let's go ahead and forget that in there, plus 1. Okay. Now we can start combining like terms. I'm going to add 3 cosine of x, 3 cosine squared of x. I keep forgetting that drop in the cosine squared. This goes away. 1 plus 3 is going to be 4 cosine squared of x equals 1. All right, next, to get the cosine squared of x, I'm going to divide both sides by 4. And then to get the cosine alone, I'm going to square root both sides. So the squared and the squared would go away. I'd be giving with cosine of x is equal to, the square root of 1 is 1, the square root of 4 is 2. And don't forget, since we squared root both sides of the equation, we have to have plus or minus. So we want to find where all the cosine values on the unit circle are either positive or negative 1/2. That's all the pi over 3. So we have pi over 3, 2 pi over 3. We have 4 pi over 3. We have 5 pi over 3. It's a longer problem. All right. Number 11. We're going to add the square root of 8 to both sides. So we have negative 4 sine of x equals the square root of 8. And divide both sides by negative 4. Sine of x is equal to negative root 8 over 4. Now we haven't seen something like this, but that doesn't mean it can't be done. Technically, 8 is made up of the factors of 4 and 2. The square root of 4 is just 2, and the square root of 2 is left over, and 4 is still our denominator. But now, because the 2 and the 4 on the top here can be reduced, we have negative root 2 over 2 equals sine of x. All right. What this allows us to do is find the values, the radians, where sine is negative root 2 over 2. There are 2 of them. It is at 5 pi over 4 and 7 pi over 4. Oops, that doesn't look like a 7. 7 pi over 4. Number 12. Straightforward, you add 3 to both sides. So you have 2 times tangent square root of x equals 2. Divide both sides by 2. We get tangent square root of x equals 2 divided by 2 is 1. Now we take the square root of both sides. The square root and square root go away, so we have tangent of x is equal to, well, the square root of 1 is just 1. But again, remember, since we squared root both sides of the equation, we put plus or minus. So every place where tangent is positive or negative 1, there's 4 of them. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. All right, this looks a lot like the problem we did up here. Where is it? Number 8. Okay. Everything's already on one side, though. So what we can do is we take the greatest common factor of tangent out. We're left with tangent x plus 1 equals 0. Now if we take both of those and set them equal to 0, we can solve this. All right, so the first one's done, tangent of x equals 0, that's done. The next one would be tangent of x equals negative 1. Okay, so the first thing you want to figure out is where tangent equals 0. So again, it's y divided by x. So where is the y divided by x going to give you 0? There's 3 places. It is at 0, pi, and 2 pi. This is each the place that where you have 0 divided by 1, which is 0, or 0 divided by negative 1, which is still 0. The other spot is tangent of x equals negative 1. There's only 2 of those. It is at 3 pi over 4, and it is at 7 pi over 4. Okay. Last equation. All right, in this case, similar to the problem we just did, right? But unlike the problem that was over here with the hint, where'd it go? Right here. We don't have a hint, and none of these two terms is squared. But they both contain sine, so we're going to take a sine out. And we're left with 2 cosine of x plus the square root of 3 equals 0. So we can take both of these factors and set them equal to 0 now. The first one's done, sine of x equals 0, right? But we have to solve the other one. So we're going to subtract 3 and divide by 2. So where does sine of x equal 0? It's only in 2 spots. Actually, it's in 3 spots, sorry. 0, pi, and 2 pi. And cosine of x is negative root 3 over 2 in 2 spots. 5 pi over 6. What is it, 6? And in 7 pi over 6. Okay, that's a lot of different examples of solving trig equations. Next, we move on to sum and difference identities. Again, these are you're going to need to use your formula sheet for this. So you're going to find two terms that add up or subtract to be 5 pi over 12, while both terms that you use are reducible using 12. So we can use 3 pi over 12 plus 2 pi over 12. Okay, if we reduce both those terms, we end up with pi over 4. Yeah, that's really ugly. Pi over 4 plus pi over 6. This is the x, this is the y in your sum and difference. Since we added, okay, we're going to use the sine x plus y part of the formula. So if we do that, we're going to have sine of x, which is pi over 4. We're going to have cosine of y, which is pi over 6. All right, the formula says plus. We're going to do cosine of x, which is pi over 4. And finally, sine of y, which is pi over 6. So we have to set this up. You got to show this work that you know how to use the formulas. Next, we find the values for each one of these. It's sine pi over 4 is going to be root 2 over 2. Cosine of pi over 6 is going to be root 3 over 2. Plus the cosine of pi over 4 is root 2 over 2. And the sine of pi over 6 is 1/2. Okay. Now we just multiply. Root 2 times root 3 is root 6. 2 times 2 is 4. On the other side, root 2 times 1 is root 2. And 2 times 2 is 4. Now we can combine the like terms because they both have a denominator of 4. So we have root 6 plus root 2 over 4. And there's your answer. For 16, two numbers that multiply, or sorry, not multiply, I'm thinking of factoring. Two numbers that add or subtract to be negative 1 pi over 12. Okay, so we have, let's see what we could use. We can use, we'll just use the same thing. We'll use 2 pi over 12 minus 3 pi over 12. So we're going to get pi over 6 minus pi over 4. Let's rewrite this because it's really ugly. Okay, so now this is our x, this is our y. So we're going to put that into the cosine formula, and since we subtracted, we use the cosine x minus y formula. So we have cosine of x, which is pi over 6. Then we have cosine of y, which is pi over 4. Then it says plus. We do cosine of, the sine of x, which is pi over 6. And the sine of y, which is pi over 4. Now, for both these problems, I use certain numbers. You can use different ones. If you want to use like 8 minus 9, fine. They both work. 8 and 9 are both reducible with 12, so that would be fine. So you don't always have to use the same numbers I do. You should get the same answer. It should make sense when you do it. Make sure you're not trying to use a term that can't be reduced to 12. All right, so now we have to find the points or the parts of the points for these different trig functions and radians. Also, this is really ugly too. It's bothering me. Okay, so the cosine of pi over 6 is root 3 over 2. The cosine of pi over 4 is root 2 over 2. Plus the sine of pi over 6 is 1/2. The sine of pi over 4 is root 2 over 2. So like before, multiply square root of 3 times the square root of 2 is square root of 6. 2 times 2 is 4. 1 times the square root of 2 is square root of 2. 2 times 2 is 4. Combine the like terms because they have the same denominator. So we got root 6 plus root 2 over 4. There we go. Next, our favorite, tangent, sum and difference. Let's go. So we got to find two numbers that add up to be 11 over 12, but can be reduced with 12. So let's see. 5 and 6 won't work. 7 and 4 won't work. 8 and 3 would work. 8 pi over 12 plus 3 pi over 12. So 8 is, you can reduce both by 4. I'll get 2 pi over 3. And 3 pi over 12 would be pi over 4. So this is the x, this is the y. So we get in the formula. Since we added, and our formula is plus or minus, we're going to use the top signs. We're going to use the plus signs. So we have the tangent of 2 pi over 3 plus the tangent of pi over 4, all divided by 1 minus tangent 2 pi over 3 times the tangent of pi over 4. So that is our formula set up with all the tangent stuff and the right radians in the right places. Now we have to start simplifying. So the tangent of pi over 3, 2 pi over 3, is going to be root 3 over 2 divided by negative 1/2. Okay, so actually I'm going to move this. This is going to be the tangent of 2 pi over 3. So we're going to solve this little part first. So we're going to multiply by 2 over 1. The negative sign will stay. So all this stuff would cancel, and the 2's would cancel. We'd left with the negative sign, and then square root of 3. So this is the tangent of 2 pi over 3. So we can replace the tangent of 2 pi over 3 with root 3. It's going to be negative. Plus, the tangent of pi over 4 is going to be 1. And we have 1 minus the tangent of pi over 3 is negative root 3. The tangent of pi over 4 is positive 1. So what we have on the top is negative root 3 plus 1. On the bottom we have 1. And then negative root 3 times 1 is negative root 3, but then there's 2 negatives in a row, which gives us a positive root 3. Let's make that an equal sign. All right, so now what we can do is we're lucky that this one is not a problem where you have to combine the fractions on the top and the bottom and then multiply it to the top. Okay, so these are kind of somewhat reduced, but we can't allow square roots on the bottom of our fractions. So you have to multiply by the conjugate. Write it up here so as a reminder, conjugate. All right, the conjugate is the same terms as the bottom, 1 and then square root of 3, except with a different sign. So we're going to have a minus. We're going to multiply that to the top and the bottom. Okay, now what we have to do is distribute. How much space do I have? I'll do over here. So we have negative root 3 times positive 1, which is negative root 3. We have negative root 3 times negative root 3, which is positive root 9. We have 1 times 1, which is 1. We have 1 times negative root 3, which is negative root 3. On the bottom, we have 1 times 1, which is 1. We have 1 times negative root 3, which is negative root 3. Root 3 times positive 1, which is positive root 3. And root 3 times negative root 3 is negative root 9. Okay, so now what we're going to do is we're going to swing over to the other side here, and well, somewhat in the middle. We're going to combine the like terms. We have negative root 3 and negative root 3. That's 2 negative root 3s. All right, the square root of 9 is 3, plus 1 is 4. On the bottom, these two will cancel each other out because negative root 3 and then positive root 3 are the exact opposites. They go away. And then we have 1 minus the square root of 9, so we have 1 minus 3, which is negative 2. Since the 2, and the 4 are all the same, are all multiples, okay, we're going to divide everything by negative 2, which gives us root 3 minus 2. And we're done. That's it. So easy. All right, last one. We got half angles. Okay. So some stuff with this, again, we have this negative sign in here, which means because it's a negative rating, we're going around the unit circle. We're going to find out where that is, and then as a coterminal, and then put it into our problem after we multiply the 7 pi over 8. Oops. 7 pi over 8 times 2, which gives us 7 pi over 4, but it is negative. Okay, so if we look at our unit circle and do the coterminal of that, negative 7 pi over 4 goes around the unit circle. Remember, we're going around the unit circle backwards. It'll end up over here, and a coterminal of that is pi over 4. So if we look at the values for pi over 4, that's what we can use for our problem here. Okay, also notice, remember, in our half-angle identities formulas, you can see there's that plus or minus in front of all of them. That's going to be, again, something that we do at the very end of the problem. Okay, so we're going to put those values in here. So we're doing the sine one. So we're going to have 1 minus the cosine of, we're going to put in negative 7 pi over 4. That doesn't look like a pi. And now I screwed the whole thing up. Divided by 2 with a big square root. All right, so we talked about where that is in terms of where pi over 4 is and negative 7 pi over 4. So the radian, the cosine radian for that is root 2 over 2. So we have 1 minus root 2 over 2 divided by 2 with a big square root. And again, there is a plus or minus in front of this, but we're going to deal with that at the very end. Okay, next we have the two terms on the top of our fraction. All right, we're going to make those into a bigger fraction. We're going to make the 1 into 2 over 2 minus root 2 over 2 divided by 2. There's a lot of 2's in here with a big square root. We can then combine that top fraction. We have 2 minus root 2 divided by 2, and all that is divided by 2. We have a compound fraction. We're going to multiply this by 1/2, which is the reciprocal of 2 over 1. So we will get 2 minus root 2. Then the 2's in the denominator, these two, will become 4 with a big square root. And we're going to divide that into pieces. So we're going to have the square root of 2 over 2. Sorry, the square root of 2 minus square root of 2 divided by the square root of 4, which is just 2. And now we have to talk about the half angle for negative 7 pi over 8. Okay, so if we think about where it is with the whole thing, all right, half of it is going to be the 7 pi over 8, negative 7 pi over 8 is going to be, so that's going to be someplace over, let's zoom in on our unit circle. We're looking for negative 7 pi over 8. So if pi over 4 is here. Negative 7 pi over 8 is going to be, sorry, negative 7 pi over 4 is there. Is over here. I'll highlight it. Is over here. And negative 7 pi over 8 is going to be someplace over here. Okay, and we were looking for the sine of this. So what is the sine in this quadrant? The values of the sine in that quadrant are all negative. So our answer is going to have a negative sign out in front of it. Okay. Now we go to cosine of 11 pi over 12. So we're going to multiply 11 pi over 12 by 2 to get 11 pi over 6. Okay, so if we are going to make another unit circle so we can see it again, 11 pi over 6 is going to be someplace over here. Okay. All right, so again, we're going to look at our formula. All right, we're going to use the cosine part. We got 1 plus the cosine of 11 pi over 6 divided by 2, the big square root. Okay. Oops. There we go. So we have 1 plus the cosine of 11 pi over 6 would be root 3 over 2 divided by 2. Big square root. Again, we're going to combine the fractions at the top. We'll have 2 over 2 plus root 3 over 2, all divided by 2. And now, because they have common denominators, we can add them together. So we have 2 plus root 3 over 2, all divided by 2, big square root again. We're going to get rid of that denominator of our complex fraction by multiplying by 1/2. Those go away. And we have 2 plus root 3 over 2 times 2, which is 4. Now, we can do the square root of 4 on the bottom, so we're going to end up with the square root of 2 plus root 3 over 2. Okay, now if we go back to this, 11 pi over 12 would be someplace over here on the unit circle. So we're looking for what is the cosine in that spot on the unit circle. All right, cosine values are negative over there. Oops. So we're going to have a negative right there. All right, last one. Tangent of 7 pi over 12. So we're going to multiply 7 pi over 12 by 2. Okay, so we're going to be 7 pi over 6. Okay. I'll do our unit little circle here. So 7 pi over 6 is right about here. Okay, so now we're putting that value into our formula. So we have 1 minus cosine of 7 pi over 6 divided by 1 plus cosine of 7 pi over 6 with the big square root. So 7 pi over 6 and cosine would give you 1 minus negative root 3 over 2. And on the bottom we'd have 1 plus negative root 3 over 2. So it has a big cosine on it, or a big square root on top of it. Okay. So we're going to combine the like terms on the top by getting a common denominator. So we're going to have 2. The 2 negatives give you a plus root 3 over 2. On the bottom, the 1 negative gives you a minus, so we're going to get 2 minus root 3 over 2. Okay, so we found the common denominator by making the ones into 2 over 2 and then combining them as the two fractions. Okay, now we're going to multiply by the reciprocal, which is 2 over 2 minus root 3 on the bottom, and we're going to bring it to the top. So all this stuff cancels. The 2's cancel. Unfortunately, that part, the last parts do not. So 2 plus root 3 over 2 minus root 3. I don't know what that just did. 2 minus root 3. Oh, well, that's okay. It's going to stay. It still has a big square root. All right, a lot like our tangent for the sum and difference, we're going to multiply by the conjugate, which is going to be the same terms on the bottom, but with a different sign. It is not relevant to the top, it's just about the bottom. Okay, so we're going to multiply this stuff out. So we have 2 times 2 is 4. 2 times root 3 is positive 2 root 3. Root 3 times 2 is again positive 2 root 3. And root 3 times root 3 is positive root 9. All right, on the bottom, 2 times 2 is 4. All right, 2 times root 3 is positive 2 root 3. Negative root 3 times 2 is negative 2 root 3. And then negative root 3 times positive root 3 is negative root 9. It still has a big square root on the top of it. I didn't like that one. That's better. All right, we're going to combine our like terms. We have on the top 4 and the square root of 9, which is 3, which gives you 7. And then the 2 square roots of 3's gives you positive 4 square root of 3. On the bottom, these two terms cancel out. And 4 minus root 9, which is 4 minus 3, gives you 1. All right, the square root of 1 is irrelevant. So our answer is root 7 plus 4 root 3. Just like that. Now again, we have to go back and look at our unit circle to find out where 7 pi over 12 would be. 7 pi over 12 would be somewhere about there. Okay, so this would be 7 pi over 12. If you think about it, 6 pi over 12 would be 1/2, which would be this line right there. This would be 6 pi over 12. So 7 pi over 12 has to be a little bit bigger. So we're looking for what are the values of tangent in this quadrant. So tangent values in that quadrant are all negative. And that's it. It's a long review. I get it. There's a lot of questions on here. All right, please study hard so you can do well on the last test, and good luck.